introduction about what backend. So let's talk about what backend engineering is all about. Okay, this would be the agenda for today's webinar. We're going to talk about the introduction of the field. I'm going to introduce you to the entire field. Okay, we're going to understand what the web applications are. Okay, what are the kind of engineering aspects are there. Okay, what different kind of engineering is there. So since we're already talking about backend engineering, but what more is also there. Then we're going to have a look at a small demo accompanied with some understanding of GoLang, so that it all kind of makes sense to everybody. And after that, we're going to discuss more about what a backend engineer does, how a routine day in the life of backend engineer would look like, what choices does the industry offer. So when I say industry as in the ID industry, the engineering, computer engineering industry, what are your choices? What is it that you'd get to do as a backend engineer? What more can you accomplish there? Then we're going to look at the market. So before acquiring any skill, it is important to have an understanding of the market, what the present market is like, where the future is headed. Are you still going to be relevant after 5 years or 10 years? So those are the important things that you should know. Then after that, what does it take to become one? So this is where, like, I'm gonna say that, okay, what you need to be a backend engineer, what is it that you need to find within yourself, and to get a grasp of yourself, and you can ask these questions to yourself that, okay, whether is it something that I would really want to take up as a career prospect. And then after that, how your future prospects are with the backend engineering. Okay, so let's move on to the introduction field. Okay, so what is backend engineering? Backend development is basically the skill that powers the web. To simplify it further, all the internet that we see today, whatever is running on the web, is basically powered by some or the other kind of backend development done by any of the engineer. Backend engineering deals primarily with the functional and logical aspects of the product. So when I say product can be a google.com, your Gmail, Yahoo, could be anything. So these are all products. Okay, every company is trying to offer something to the people, to us. And a backend engineer is the person who's actually sitting behind the computer somewhere in a small, in front of a laptop, and he's trying to code that thing so that it works. He's trying to put the information out in a reasonable way so that it makes sense to everybody in general, to each and every one of you. So when we say, like, there's a common misconception that goes around in the people who are not very familiar with the web, that every time I type something in Google, there's a person sitting behind who actually decides what needs to be shown to me. But that's not the case. Okay, we all know Google is way faster for any human to comprehend that kind of search. So that's all those search result related result, those algorithms, all those engineering stuff is done by some backend engineer. And the tech of backend is a combination of server applications and databases. Backend engineering not only requires you to code, but it also requires you to have a more broader understanding of what goes into building a product first. Okay, so what we see on our screens when we say google.com is just a small page, but there's a lot that happens behind the screens when people are not which people are not able to see. Okay, there's a lot that happens. There's a million of calculation that happens just before you get to see your first result. Okay, so backend engineering basically deals with all the complications that arise out of a seemingly simple application. So the most simplest application that I would quote right now is your Google search. So let's say if you want to search that what is the weather today. Now Google does not know where you live or what is the weather around you. They don't know that. Probably the request that you're sending right now is gonna end up somewhere in USA, some server sitting in some remote location, but still they're able to showcase all the information to you. And how does that happen? Simply because there's a complex algorithm that is written in the background, which runs, gets your location based on your IP address. It figures out your location, then contacts the local department there, get your weather update from the local weather service, and then populates the result and shows it to you. Okay, so all that millions of calculation, contacting each and every agency and getting all the information and putting everything in the right place happens in flick of a second. So that's a simple application, yet the design that has been there in Google backend is really complicated. Okay, so but then a good design, an efficient design, is what determines how smooth the user experience is. Okay, so to us as an user, it seems like a very simple thing, but there's a lot that has happened, and people have put in a lot of hard work just to ensure that nothing goes wrong and every time everything is super smooth. Okay. Now, before we dive deeper into backend engineering and I, bombard you with a lot of words which would stop making sense after some time, let me give you an understanding of what web is, what web comprises of, and every time I'm going to use a technical word, so it kind of makes sense to you. Okay, so when I say web applications, I mean any application or any kind of software, be it on your phone, your camera, your mobile phone, your TV, your laptop, your desktop, or even in your car in these days. So any kind of software which utilizes a web browser or any kind of web technology, which basically allows to perform some kind of task over internet, be it your phone trying to send a WhatsApp message to another person, or be it your car trying to connect to a map service to show you directions, or your TV getting data from Amazon Prime to show you more shows. So all those things, they just happen over the web. Okay, and this is the hidden traffic which you do not see. Every time you go to an ATM and transact over the ATM and try to withdraw some money, that's still using internet. All of that happens using internet, because the internet is a lot more than what we get to see. So this is called web. Even your ATMs have some kind of web application setting in which talks to a bank server. So modern web applications are platform independent. So now when I say platform independent, I mean you have a Flipkart running on your browser, you have the same Flipkart app on your phone, you can have the same Flipkart app on your TV, and sometimes even in your automobiles. So a single so it's not like that they have written four different applications. Okay, that this application will work for mobile, this will work for TV, this will work for web desktop. It's never like that. It's a single application which serves everything. Okay, so that's how that is what makes your web applications platform independent, and that is what makes them more efficient. And this all is done by a lot of backend engineers sitting in there coding, and making sure that whoever you are and wherever you are requesting the content from will still be able to send it to you, okay, in some specific format that you can try to understand. Okay, so the same application can be accessed over mobile or a desktop device. I've not mentioned TV because most of the applications are not there, but yeah, you can access them over TV as well. Now, web application allow easy integration with other applications as they all use the same communication language. Now, I'm speaking right now. So the language is English. Everybody is able to understand English. If I switch over to Hindi, some of you may understand, may not understand. If I switch over to Kannada, again, the same scenario may happen. Okay, or if I switch to French, maybe none of you might be able to understand. So that's the thing. But in case of internet, because the reach is so far, so huge. Okay, there are so many devices, so many applications, and it's all globally connected. So everybody has a standard language. Okay, the Worldwide Consortium, as we know as WWW, has set out some basic standards which are followed by everybody who would want to use the internet. Okay, and the most common language that is utilized by everybody is called HTTP or HTTPS. So when you're in your browser and you say google.com, you would notice that just before www.google.com, there is either HTTP or HTTPS. Either of that is written. So that signifies the language which is used by the application to communicate over the internet. Okay, there's another app language which runs internally is called TCP, but we'll not touch that. This is, I think, sufficient to understand. The ease of integration and ability to serve multipurpose applications is what makes the web application so powerful. So what make the amount of freedom a developer has to talk to another application. And it's not just like that, okay, I am building a web application, so I can only show it to a browser or a phone. I can even talk to your web application. So web applications are so, how should I say, they're so vast and they're so diverse that one application can talk to other application and never show up to the user. So let's say there's an application A which only, as in like compiles a list of users that are there. There's another application B which just fills in the phone number for the user. That's it. So application B is not useful for a user, but for application A, B would make more sense because it would want more data. Correct. So there are many web applications which are never there to help any end user like us, people who are the end users. but they are there to serve another purposes for other applications. Maybe just simplify some complicated tasks which other application might be trying to achieve. Let me give you a small example and show you what a web application basically functions like. So I'll just go to google.com, but I'll also enable, so this is called as a debug mode. Now, when I say google.com, you would see there's so much that has happened. Okay. Now, all this information, if you see, is coming in from Google. Okay. There's a specific server which is sending in all the data to the Google. And anytime I say, let's say, hello world, so whatever query that I send out goes to Google. Google decides to, process that, generate some information, and then send it out as a response to me. So this is where all the response is. Now, this response is a lot more complicated for us to understand because this is in a specific format which most of the backend and the backend applications use to communicate with their clients. But this is how the information is sent throughout to everybody. So this is how it works. Okay. Now coming back to where we left. Correct. Now let's try to understand more about the web and the web applications. So internet, as I already told you, is what we commonly know as the web. Okay, and internet is critical for handling on your web applications. Internet comprises of all your IoT devices, satellite traffic, GPS, banking data, telecom data, you name it. Anything that functions today uses internet. Even if your mobile phone, even the video calls, audio calls that you have over your phone, or if not your phone directly, let's say your Wi-Fi routers, everything is using internet these days. Okay, so this is all digital. So all the digital communications that happens over web is managed by, or it is done by some other applications trying to connect to some software to convey some information, send out a request asking for something, or send a response, send like response to a request. So in our case, just the example that we saw, what I had done here is when I said hello world, I basically sent a request to Google saying that, okay, please send me this, please tell me what hello world is. And in response to that, Google sent out a lot of information which we can see here. Okay, so this is a simple mechanism of request and response, and this is how majority of your web applications function. Okay, they're just either trying to get some information or send some information. Now, web applications, as the name suggests, are designed to work over the internet, providing their services to various devices and platforms. So the same Google is available over all your devices. Now, the reach that Google has is your cars, TV, everywhere. You have a Google search working for you. Now let's understand what web applications are built of. Now I'm telling you all this because in the next slide you'll understand that, okay, why we need to understand web application before we actually understand backend engineering. Okay, so let's talk about this first. So components of web applications. What are the various components that are involved in building a simple web application? Okay, so focus your attention to the diagram. There is two main components, a server and a client. A client can be a mobile phone or a browser, depends which device you're trying to access the application from. Okay, a server, on the other hand, is a single unit sitting somewhere, could be in any data center or a cloud center, or maybe running from my own home. So a server is basically a centralized place where the web application is running. Okay, which is listening to the incoming traffic and trying to understand all of that and send out a response. So a web server basically has three logical paths. Okay, very distinctively, it is a lot more, but simplify the whole stuff. Basically, there are three paths. There's a web server which is responsible for serving the application. Basically, it handles all your communication that goes inside and outside of the web server. Your entire web application, whatever comes in from the clients and whatever goes out to the client, is done by this guy. Then there's business logic. Business logic is basically where you decide what you want to do with the application, what you want to do with your user request. What you want to send to the user. In case of Google, when I sent out hello world, okay, web server would have interrupted my request, and okay, it would have understood that, okay, this guy is asking for the meaning of hello world. It would have sent it to the business logic unit, where a decently complicated algorithm would have run and tried to churn out as many possible answers to the hello world request. Okay, and then it would have sent it back to the web server. Now, in order to get all the information, from various sources, there is something called as a data store, or in simpler term, database. Database is where all the information is stored. So every information on the planet is stored in some or the other database. There is maybe not on my server, on some other server, or some or the other place, but every piece of information that we have today is stored in some database in some or the other form. Okay, and it is made accessible through different applications, obviously. So every application has its own database, and Google does the same. They just read information from the database and decide, okay, this guy wants hello world, let's get all that information, collect it, format it in such a way that the client can understand it, pass it on. Okay, so this is how a simple web application understands what you're asking for and tries to send you the information. To go deeper into the both the components, a client is where the user is. Basically, a client simply means the user, that is people like us, you and me. Okay, so basically we are the ones who demand information. Any app, any web application that runs today is because of people like us. If the users are not there, the application is not useful, to put simply. So let's say if you open Flipkart right now, you are the consumer. Unless you would have opened Flipkart, there's no need for Flipkart to exist. But because you had a need and you wanted to look up something or buy something, you would have opened Flipkart or Walmart or any application for that matter. So you're initiating a communication. You're the initiator of a communication that has to happen between your device and a server application running there. Okay, so all the clients initiate all the communication. They demand information based on the user request. So I, as a user, would want to see more details about a new phone that is coming up. I would click on that phone image, and suddenly the client application, which is on my device, would send a request to the server, say that, okay, hey, this guy needs all the information about this device. Please send it across immediately. And the information comes and I get to see. The client can be a browser UI like what we see in Facebook, LinkedIn, etc., or it can be a phone application like your MS Word or your PUBG mobile game, if you see, or a Flipkart application. Could be anything. Okay, so client is referred to as the client development, where your applications that the user interact with are usually fall under the category of UI development or front end development. If you're viewing the same application via some phone app, then it would also come as under mobile development. Now, coming to server, a server is what we see as as a backend. Backend is where all your business logic and data storage is. A server implementation is hidden from end user and may never encounter it. So you as a end user would probably never get to see what is there in the what algorithm is written in the Google, or how Flipkart is uh, generating all that information and sending it to you. So we as end users may never get to know that, simply because it is all hidden away from us, and only information that makes sense to us or that we request for is sent. So the server development happens in many languages like Go, Java, etc. Now, and this is branch of engineering, which is like the branch of engineering which deals with server development or the server side work, is mostly the backend engineering. Now, there are two types of engineering involved. One is the front end. Front end is the branch of engineers which deal with the development of user interface, like components like web pages or mobile app UI. So if you see this, whatever the design that you see right now, okay, is all written in HTML. There's a simple HTML here. Many of you, I don't know how many of you understand HTML code, but this is where a simple HTML is. Okay, and the entire thing is done by some engineer at Google who would have written this simple, crisp design. So this, whatever you see here, is all about the UI development or the front end application development. If I want to see the same application over to my phone, okay, so this would come onto my phone, and then again, now it's mobile application. It can be a mobile application. If you open it on your phone, again, it's a mobile application. So basically, anything that deals with what a user gets to see is your front end development. Okay, is where your UI development would have happened, and somebody would have written a beautiful piece of HTML code to show you all the things in a proper way, which would make sense to you immediately. Okay, so UI development happens using languages like HTML, CSS, JavaScript, React. So there are so many Angular. There's so many languages in the market right now, and every language has its own purpose. But the crux of any language, the crux of any kind of UI development still happens to be HTML, CSS, and JavaScript. Okay, so these are the core fundamentals of any UI. Front-end development is all about developers' creativity and understanding of the understanding. So when I say understanding, that means the understanding of what the user would like to see. Okay, so a front-end engineer's job is as much as it is towards engineering, it's also towards how creative the person is. Okay, and how efficiently are they able to utilize the space that they have, the screen space, and show as much information as possible, and but at the same time making sure that not to clutter everything out. A UI developer would determine what your user experience is going to be in the application, what you will see, what you will perceive. Okay, and whether you like it or not, it's all going to be dependent on how beautifully the UI is done. Okay, most people just sway away from the application because they're not able to understand what's going on the screen. Simple fact, because there's probably too much information, or the design is too cluttered, or something like that. Now let's talk about backend engineering. So backend vertical can be classified into two sub verticals. We're going to talk about application development and database management. Backend engineering is like the backend vertical of the engineering aspect is vast. Like, it's very vast. There are a lot of components that go into building up simple web application, and there's just I'm classifying this as two simple sub-verticals, saying application development and database management, but then these can be broken down further into a lot more complex pieces. Now, database management involves solving complex business problem backend development involves solving complex business and engineering challenges in most optimal way. Now, what does it mean when I say that most optimal way? So like we saw the example of Google. Would you think it's humanly possible for anybody to sit and immediately figure out that, okay, this guy's requesting for some information and I need to send it immediately? And even if they do, would they still be able to do it in 0.65 seconds and generate over, I don't know how much is that, some billion results? That's not possible. That's not practically possible. But so how does that happen? This is where the efficiency of a backend engineer comes in. The kind of algorithm that they write makes all this happen. Okay, backend engineering basically does all this. Let's jump on to who is a backend engineer. Let's talk more about the role itself. So a person who codes, maintains any application's backend, and resolves problem. Very simple, right? Either you are coding an application, you're maintaining an application and keeping it running, or trying to come out a solution of a problem that you're facing in real time right now. So Google was invented because people were not able to find pizza shops nearby. They were struggling with getting simple information in college. Facebook was invented because Mark Zuckerberg could not find more friends. He was not able to understand whether the girl he looked at was single or not. So those were the simple problems that they faced up at that time, which today is not a big issue. But at that time, when the internet was in its infancy, those were a real big problems, because the sole meaning of communication was either you meet somebody in person and talk to them. So all those things, okay, those were the problems that they tried to address, they tried to resolve, and that's where they did those things first. Okay, they tried to they coded out the algorithms, they coded out the solutions, and then they ran them. Okay, and as and when the time progressed, when Google became hugely popular or Facebook became hugely popular, it was impossible for one single person to keep the entire application running. Now you may ask me that, okay, you've already solved the problem, everything is running fine, what is the problem? Where does the issue start? So let's say there's a road which is 50 meters wide, and 5 cars can run easily on the road, like side by side. Now suddenly the town progresses, time evolves, and now the cars are bigger, or maybe trucks are also on the road using the same road. Now in that case, the road which was able to fit 5 cars is now able to fit only three, maybe one truck and 2 cars, or maybe two trucks only. Now in that case, the amount of congestion that you have on the road is gonna increase. You're gonna struggle. Now what choices you have? You either find alternate routes, you expand the road, or you control the traffic movement in such a way that anytime there's nobody gets to stop, nobody has to stop, everybody keeps moving at a constant speed. So those are the problems that happens in engineering as well. When I write an application, I cannot just forget about it, I have to keep evolving that. Okay, so those are the real life situation, the real life problems that happen when we see that, okay, some application went down and did not come up. They went down because the traffic was too much and they just could not handle it. Now, devising strategies that best suit the use case, simplify the problem, and write code to the to achieve the targeted goal. The targeted goal is to have an efficient code. The targeted goal is to make sure that my user never complains me that, okay, hey, your application is not working. Okay, so I have to come up with the strategies. The problem that I just gave, there could be many solutions to this strategy. One can simply come up and say that, okay, hey, let's ban the trucks on the road. You still will be able to fit 4 cars, but then I need a new road for the trucks. So what is the best strategy? Where would I spend less money and gain the best outcome? Those are the strategies that I have to come up with. Those are the similar problems a backend engineer would face, because they will have resource crunches. They may not have, they'll also have financial constraints. Your company may not be super rich all the time. Okay, if you understand that, some of you might have read the news. So Google went down, I think 2 days back. Google servers were not working simply because Google ran out of storage space. So imagine, if Google can run out, anybody can run out. Now, responsibilities involve writing APIs, writing code to interact with database, creating libraries, working on business processes, data architecture, and much more. So the list is endless. There's a lot that happens in the backend API, in a backend engineering, and there are various components.